Hello everyone and welcome back. So in this video we're going to pretty much pick up right where we left off in our last video. We're still talking about just getting basically set up for RStudio. I'm going to keep the script file exactly where it was in video 2. So we've just loaded the tidyverse package that we downloaded. We just loaded it into the library so that we can actually use all of the packages that are collected within that package. It's actually a collection of 8 packages. And we're actually going to just start out here by loading the data set that we previously left off with, or at least in class. So this whole line that I just pasted into the script file, this was given to you all in the Slack channel for the class. This video, of course, is going to be recorded in the fall 2020. For any further classes or classes that come after this, please double check the Slack channel to make sure that this is the correct link for the data file that you are going to be using within the course. So what I've done here is I've created what's called a .r data file, and this is a data file that has all the tables and data sets, what we refer to as data frames, that we're going to be using throughout the course. Now, I want to kind of talk about this one specific line of code and kind of break it down so that you understand what it is. Of course, you kind of get an idea from the library function that we used, is that we're treating this like an actual function. So there's going to be a word that's usually the title of a particular function. You open up parentheses, and inside of that it's going to be a series of arguments that you give this function, and then it will take those arguments and execute an output. So notice here the first word you see is load. We open parentheses, and so we're using the main function is the load function, and then we have to usually specify what we want to load. So you would use this load function if you have some type of data set that's already locally installed on your hard drive or saved on your hard drive, or that belongs in another package. You could just call it by name and go. In this case, though, our data set resides within a Dropbox folder that's publicly accessible via a link, and so we put in the URL function, and so this kind of adds some additional functionality, and this is one of the reasons why R is such a useful, flexible programming language, is because the argument inside of the load function is actually a separate function in and of itself, and that is the URL function. Now, alternatively, we could have just defined the URL function as a separate object name, and then inside of that object name, we could have put that into the load function and broken this up into 2 lines. But instead, I've just wrapped it up within 1 line, mainly to show how flexible this software can be. So, the URL is a shared, publicly available link to this file. So it works just if you're ever familiar with Dropbox, it's a place to share files in the cloud, and so then you can just hit the share button and get a shareable link, and this is that shareable link. And there's actually a separate video on how to use this to install other data files, and I'll link to that video above. Now, here we're loading the full 312 data set, so I'm just going to go ahead and execute this line, and then you'll notice over here in the global environment, it'll pull together a handful of different data frames. So we're specifically interested right now within this portion of the course in the money data frame. So we should be, about the time you're watching this video, we should be right in the middle of talking about monetary aggregates. So it probably would be helpful for us to view this data frame. Now, there's a couple of ways that we can view the data. This only really is useful if you have a small enough data frame. If your data frame is relatively large, you don't want to necessarily do this. So we're going to use the view function. Now, there's a couple different view functions. The main one that's in base R is a capital view. So you'll notice that the V is capitalized, and that's particularly important, and then you can just specify the object name that you're after. Now, within the package Tibble that we previously loaded within tidyverse, there's also a separate function with the lowercase v as well. If you don't have Tibble loaded, i.e. you either don't call the tidyverse library or call Tibble directly if you're working under a new project or a fresh environment here, then you won't be able to use this lowercase v. So I kind of encourage people to use with caution here. I usually just use the uppercase v just in order to kind of avoid any particular issues. So we can execute that line. Another way to actually get that is to actually just click on the money object once, and it'll do the exact same thing. It'll print the actual code down here below within the console, and then of course a preview window of the actual data frame shows up. So this data frame has 4 columns. The first column is the date. This is weekly data that starts in 2000 and goes into 2020. Let's see where it goes because I actually don't remember off the top of my head. Yeah, so it goes to August 31st, 2020. And then the other 3 columns contain data for M1, M2, and MZM. And previously we had talked about this in class. Those particular variables for M1, M2, and MZM are actually growth rates of those various monetary aggregates so that we can actually plot them. So I guess at this point we probably should just go ahead and give these a plot and go from here. So we're going to use the ggplot package in order to do that. I mentioned in class that ggplot is actually stands for GNU Graphics. The actual full library is called ggplot2, so be careful with that. The main function that you want for ggplot doesn't include the numeral 2 in here. But this is a very robust package for plotting 2-dimensional objects. So the first argument here is actually the data set that you want. Be sure to type in data and not date. A lot of students will make a tiny typo here, and the whole thing it'll just say, nope, we don't know what you're talking about here. So just be exceptionally careful with the coding here. You have to be very precise. You don't have to include the spaces around like the equal signs or the commas that I'm going to include. I do that mainly just for readability's sake. But you do have to be very precise in what you type, the actual words, and make sure that commas and everything are actually all present as needed. So for this, we want to put the money object and define the data object as that money data frame that we have there. All data files in ggplot2 must be in a data frame format. And so that's kind of, I'm going to go down here to the console here real quick, and I'm going to type in the function class, and then I'm going to type in money, and we can see that the actual class of that object is what we refer to as a data frame. Now that's a very specific type of data object here within R. It has some very specific properties. All data objects in ggplot2 must be data frames, so just keep that in mind. The second argument that we're going to put here is going to be another function, and it's going to be this AES function, which stands for aesthetics, and aesthetics of course means how things look. So we're going to open up our parentheses there. Notice we have 2 close parentheses, so just be extra mindful of that. And so here we have to define what goes on the x-axis and what goes on the y-axis. On the x-axis, we're going to define this as the date column. So let me toggle back over to the money object. Yeah, so we have this column date, and so we want this to specifically be the date column here. And on the y, we're going to define this as our M1 column. Great. And then I'm going to end this with the plus sign, and I'm going to enter. And things will kind of auto-indent. I usually try to auto-indent inside of functions that have multiple arguments here. It just kind of helps to increase readability. It's not necessary, but I just like to do that. And then, of course, I'll also hit enter every time I have a plus sign, just to kind of help with readability. So this will define a ggplot2 2-dimensional plot where x is on the or the date's on the x-axis and M1, which is going to represent the growth rate of the M1 monetary aggregate, is on the y-axis. But this doesn't tell ggplot what type of plot to actually do. So it's actually, if you just ran the first part of this without that plus sign, it's just going to present a blank graph because you haven't told what to plot, how to plot it. We don't really know what it should look like. We only know what variables go on what axes. So we want to use this geom kind of prefix here, this geom underscore, and this actually there's a whole category of various different types of plots that you can use that start with geom. And so here we're wanting specifically a geom line, and because we've already defined the aesthetics of this in the main ggplot argument, we know what's going to be on the x and y axis here. We don't have to put in any arguments for geom line. We're kind of done after that in that regard. So this will automatically give us a line plot where our y value that we're plotting is going to be M1 over time. Now I'm going to add an additional kind of command to this to kind of make this a relatively prettier graph, if it was it were. So I'm going to use the labs command, and then here I can define what are going to be the labels on the X, Y axis as well as the title. So ggplot will automatically put on the label for the X axis and the Y axis the name of your X variable and your Y variable. Well, I don't necessarily want just this generic date at the bottom when there's already going to be dates printed along the bottom. So I'm going to take the label off, and so I'm just going to put quotation marks with nothing inside. Then I'm going to arrow out, hit comma, and hit enter again, and then I'm going to define the Y variable label. And inside of quotation marks, I'm going to put %, since after all this is a growth rate. And then I'm going to put title. And inside the title, then we're going to put growth rate of M1. Not exclamation, M1. Great. So excellent. So this should give us a relatively decent looking plot. We haven't defined any colors here, so this should give us a black. Since it's just one thing that we're plotting, it should give us just a single black line, and probably with a gray background. So that should be exactly what we would expect. Everything looks good. Let's execute. So usually whenever I execute these, I just like to put the cursor on the top line. I don't know, you don't necessarily have to, but I'm just going to do that. Execute that. ggplot's going to think for a second, and then right there within the plots tab, it'll automatically load. Now, if we want to make this bigger, we can hit the zoom button, and this will actually do a pop-out window, and this is resizable. You can drag it. It'll kind of re-render itself to make it a little more visible. So here we have exactly what we would have expected, exactly what we gave it. We have a plot of the growth rate of M1 over time, starting in 2000, going to 8 months into 2020. We have no label along the x-axis because we already have the tick marks for the individual years, and so that's self-evident enough. Along the y-axis, we have %, and then we have a nice pretty title growth rate of M1. So we talked about this a little bit in class, and I might as well just go ahead and give this a little bit of an interpretation here. We talked about the historical significance of some of these individual spikes that we see in the data. We certainly see a really big spike happening right around 9/11. This ended up being a very important date for monetary policy in the United States. It was one of those events that initially on its face should have nothing to do with monetary policy, but because the central bank swooped in to increase reserve accounts at individual depository institutions by such a large amount, and then a month later pulled the vast majority of it back, it ended up calming markets, and it ended up having a really positive stimulatory effect because markets didn't panic, and as a result, banks didn't close. And this ended up being one of those events where the central bank said, ooh, this could work in the face of other crises as well. So then when we have individual spikes happening during the 2007-2008 financial crisis, we see this spike up. We have another shock happening here around 2012. And then we have some more movement happening here in the face of the COVID pandemic as well. So this kind of becomes a roadmap for the central bank in terms of the extraordinary or heterodox monetary policy efforts that they are going to end up taking on that really are going to, in broad strokes, define what happens in the 21st century. So I'll end the video here. I'm going to continue on with this specific script file. We're going to save it in our next video, and then we're also going to plot both the growth rate of M2 as well as MZM as well at the same time. So great. Thank you very much for watching.